So the first for the agenda today, we'll just go quickly through the house rules, introduction and agenda. Today we'll just go back a bit on FHIR basics and do some recap on the essential things that we need to have in place for today. Then we'll go a bit in depth on FHIR REST, which is the normal or the starting paradigm for data exchange in FHIR. We'll extend a bit on that, on how to exchange resources or groups of resources, and we'll mention or we'll see how the other ways of exchanging FHIR content relate to that. Then we'll go a bit more in depth, although still superficially, on the main approaches. So FHIR messaging, FHIR subscriptions, and FHIR documents. In the FHIR documents, we will have some more detail on the reference architecture for using FHIR documents, which is IHE, MHDs. And at the end, we will go a bit into how do you choose between all these possibilities. So where we can make lots of choices, it's good to have some criteria or some ideas on how we can discuss. And then we have some time for Q&A discussions. At any time, please feel free to put the questions in the chat. I would also like to share with you, oops, let me just, this link. So we usually have a Google document that we use for exchanging some ideas. So if you have some ideas on how to, this, can you see it? Do you have the chat? I hope you have the chat. This document, if you go into this document, you can put your ideas and any questions that we need to park, or any things that you want to address, or if this gives you an idea, like it would be nice to have a future session on that topic alone, etc. Just feel free to write something there as in terms of future plans. This also helps us to define our roadmap for trainings, because we put in a way of doing things, but if you have other ideas, it's always good to have influences on what we are on how we are driving our webinars. So feel free to drop there any questions, any topics, quick questions that you want to answer on the session. Please bring it up in the chat, in the Zoom chat, and I will check, and Luke as well will check this regularly. So let's go back to the presentation. The first thing is I can leave it in this mode. I hope it's okay, because it's pretty much the same thing as we maximize, and I don't have to jump through windows. So what we are doing is a set of webinars on FHIR. FHIR is a trademark of registered trademark by HL7 International. And the fact that we use the FHIR brand does not mean that we are endorsed to use FHIR, that we are endorsed by HL7 to do this. These are not official trainings. These are just, let's say, welcome sessions, welcome webinars for our implementing partners and for our community to have a good reference of what are the things to consider. From this introduction and from your own expectations, you can always follow FHIR courses. You should follow FHIR courses, and those are available in the hl7.org web page. So if you go to the website, there will be some official offerings for HL7 training, and that is recommended to follow as you get more and more depth in different areas of FHIR. This presentation is also a collection of freely available materials. So everything that we are providing, it is taken from some source, some free source somewhere. They will be quoted when that's necessary. And in the same way, what we are doing is freely available, so you can take the content, you can share it. Just please give us credits as we give to others when we use their materials. So the session for today, or the goals for the session today, is that at the end of this, you should be able to identify the basic exchange mechanisms for FHIR using REST or others. Actually, well, we start with REST and then explore the documents and messaging paradigms. Those are the key things. The other ones, we will be aware of them, just to see that they exist, so that if we have a specific requirement, we can map our requirements to those other paradigms of exchanging information. We will check the impact of and criteria of deciding which one to use, and we will go a bit in depth on seeing a reference architecture specification for using FHIR documents, which is MHDs by IHE. With that in mind, I'm Jose. I'm working with Path, and I'm working on standards, as well as my colleague Luke Duncan, and we are both standards technical standards advisors, and we provide support for our standards community, both within our projects and to the broader community, like we are doing now. If you want to have a more detailed description, I think I'm with a short description. I'm good. Do you want to introduce yourself, or you can do it?
Yeah, I think that covers it. That's all.
Okay,
that's me.
Thank you. Okay. Yeah. First part of our presentation. Oh, okay. I should put this in presentation mode, otherwise you'll see the content there. So in our first session, we have discussed what is FHIR about. So FHIR is about having some resources that contain some elements, and those elements have some data types, and some of those elements, they are bound by a value set, so typically coded things. So we explained a bit of that, and in there we discussed that normally or usually a FHIR resource is the atomic unit of data exchange. So when you exchange something in FHIR, you do this resource by resource. That's not always the truth, as we will see today, but normally we take one resource. So resource by resource or groups of resources, that's our unit of exchanging data, or our smallest unit of exchanging data. Today, we are going to see how that gets transported in the sense of how do we do REST APIs, messages, documents, services, not so much. We'll do subscriptions, and GraphQL will just introduce that. So today is all about transporting data, meaning exchanging data. What is the paradigm for transport that we are using? So FHIR REST. I don't know if everyone is familiar with REST architecture, I would say, with the RESTful architecture. Very briefly, and also my knowledge is not very good on that one. So RESTful is representational state transfer. It's a web service technology that basically determines that to exchange some data, you have you strip the state out of that. So when you exchange something once and again, the state is not part of the transaction. So let me see if I can come up with an example. If you create a prescription, you submit a prescription to a system, normally it doesn't. So, and because the communication can be broken, and you might have to resend, or maybe you send a prescription and then you send the patient information, and who knows which package comes first, and based on that, you don't expect the receiving part. You don't expect the parties to be aware of the state of that. So the communication has to have enough information to dictate what should be done, regardless of the current state of the machine. That is pretty much the limit to my knowledge of how REST came to be. But what matters most is the most common web technology today. And it's for FHIR is the most common approach and the starting point for what we are usually discussing. REST interfaces, or RESTful interface, or REST architecture, it handles the resources with the typical REST verbs, and the REST verbs are get, post, put, and delete. There are others, other verbs, but basically we say get is when one system tells another, get, I need to get this data, and then you say get me this patient, or get me that medication, or get me that device, or get me that location. All of these resources, and those resources are the ones that are standardized in FHIR. And when you do that, you get a response, and the response is one resource, and that's very important for what we are going to do today. When you issue a request, you get a response, and that response is one FHIR resource, not two, not three, just one, not zero, just one, well, zero if there's an error, but just one FHIR resource. When you do a post, you are doing, well, you're posting something to the other server. You're saying, I want to create a new patient, or I want to create a new prescription for the patient, or I want to create some other object. So you just post that and you provide the data with it. Another verb is to put, where you say, I need to put some additional information or some different information in that place. So you can say, I want to create patient one, or I want to create one patient, but then you say, I want to create or update the patient number 3. I don't know what is there, but I want the patient number 3 to be exactly this. I want to update something. And then you use a different verb, because post says create it anywhere you want with any identifier. The put is you create one specific instance that you already have identified, and if it exists, it will get updated normally. And so that's the difference between post and put. And delete is, of course, deleting one resource or many resources at a time, if that is allowed. While this is the most simple thing about REST, so it's just exchanging data based on this. The parameters that we use in REST, they will determine what the content of the response is. For example, if you have search parameters, if you have format modifiers, anything that is part of the FHIR syntax. And we did have a session on FHIR search, so feel free to go there to our webinars and see if you haven't the way that FHIR search works. It's important as well for mastering the exchange. But if, for example, we have a request like this, let me just, sorry, I need to exit this. This is a request. So if I issue this request to the server, basically this is saying I want to get from this server, I want to get a patient, but which patient? This one, but I only want to get a specific version. So I want to get the iteration number 5. So let's say the version number 5. So FHIR does keep versions, and this is just one example of parameters. And this is another example. I want to have it in a pretty format. So you can have several parameters. Those are in the search session. But when you do this, when a system talks to another system and does this, and if I have a get, the easiest thing to do it is to put it on a browser. This is it. So this is what FHIR communication comes about. This is a RESTful communication. You just issue the request get, and the server says, okay, here is the response to your request, which is a resource type patient, of course, because that's what we requested. We requested patient, and here is the content of the patient in the version 5 as was requested. If I don't do that, I just don't want to do that. I don't want to focus much on that, but if I remove the history, it will normally get me the current version, which in this case is also the version 5. But this is this is how REST works. I don't have any specific examples of doing posts, but I can show how it works, and that's something that, let me just use the standard server. It's better to show this than to just describe it. So if I go, for example, for a patient, so this is the happy server. This is the one of the reference servers that's out there. And when we do operations, we can have read. So this is a get. We can delete. We can create, which is the post. We can update, which is the put. So those operations correspond to the REST verbs. And we can, for example, read an instance. Let me check what instance here. So I can go here, and then I can say read. This does exactly what I was just doing before. And it says this is the request. It's a get on this URL that for this patient. Other things we can do is I can, for example, go here and post another version of the same resource. Let me do just that. So I'm going to update this resource. I'm going to, sorry, click the wrong button. I'm going to update the resource. I'm going to say it's the same thing, and I'm just going to remove this. But I don't have to say which version this is. I'm just going to say, I want to update patient with this ID. And what I'm just doing now is simulating what normally a system would do. And I want to say that the patient is the same thing, but it has, let me just change something.
Jose, could you zoom in a little bit? It's hard to see.
Yeah, okay, sorry.
Yeah, thanks.
Consequence of having a big screen. So let me see. Okay, I'll do something harmless here. This is a test server, so there's no expectation that this will be used for anything except for demonstrations like this one. But if I want to change this, I'll just change the language, which is actually the same thing here, and I'll just copy this in case something goes wrong, and I'll just do an update. Oh, everything went wrong. So what is the content? Type patient, okay. This should definitely work. Okay, it doesn't work, so sorry, it's a demo factor. So what I'm going to do is just create a new patient exactly like the other one, but with the new data. So I'm just going to make a create option. This should work. Yeah, and it does create. It gives, well, I think it actually gave it the same ID. Okay, and it's, yeah, this is the request. And this is the response. And it does, yeah, so indeed, it just created a new patient. So I just created a new patient on the server, and the server, depending on the server assigns it an ID. So without going, I did not want to go too much into the technical sides of this, but I just wanted to see under the surface, this is how it works. You issue one request, you get the response to say, this is what happened. If there's something wrong, then you get an error message. In the other case, I got an error message in a human-friendly manner. In this, but normally computers will get some error codes that they can handle. And so this is pretty much what you can do. You get the patient. If you search for a patient, or in another request, and let me issue that request, that's also an interesting one. In this request, we are saying, get me the patient and everything related to this. So this is a standard operation that FHIR has, and it gets me everything that points to this patient. So all the observations, all the medication requests, everything about this patient. We can do that, but in the beginning, I said, and in the other session, as you remember, that the unit of exchange here is always one and only one resource. So if I do this request, there's going to be one problem, which is the system will want to give me several resources. So I'll issue the request in a second. But so as we see, often the communication includes several resources and they are related to each other. In our case, everything is related to the same patient. We can have different queries on the server that return the patient and only the observations of a given type, as you recall from the search session. So as a brief recap as well, how do we handle that? So if multiple resources have references, we can point those references, so we know that this patient is referring to the other patient, or the encounter is referring to the encounter.
Sorry, Jose, can you hear me?
Yeah, I can.
It's still totally unreadable. Could you enlarge this, please?
I will enlarge. Oh, let me see if I can.
Many thanks.
Let me see, where is I'll have to put in slideshow mode again. Is this readable?
It's at least a little bit better.
Let me see if I can zoom in somehow. I don't know if, yeah, there is. Nope, no, it doesn't. The browser doesn't allow me to zoom in because I'm in presentation mode. Let me see if I can do this here. So we know that in different resources we have references. So the subject is a reference to a patient or a group, whatever resource this is. So we have references, and as we've seen in previous sessions, we can have what we call literal references. So this is a reference to a resource that exists, or logical references where we just put the patient ID, for example, and that's not really a FHIR resource, but we still have a reference. We can still track the patient. But in case where we have the literal references, so when you actually can say, dear server, get me this patient and all the resources that you know that are pointing to this server directly, to this resource, that are pointing to this patient directly, to this unique resource. How would that work? So the problem is, how does that work if we only have one resource as a response? That's where we have a resource called FHIR bundle. Let's see if I can. Okay, I'll have to do this and this. So we have a resource called FHIR bundle, which is dedicated to contain other resources. So the FHIR bundle is just a FHIR resource, and it contains entries, 0 to many entries. This allows us to issue, for example, a request, and if the request is supposed to contain many resources, we don't get many resources scattered, we just get one bundle with different resources. And that's why, and this is important for us today, when I do a search, I will get a bundle that says this is a type search set. If I do a document, like we will see later, I will get a bundle of type documents. So bundles have types, just to say what kind of content is in there. So it's resources, but how are those resources? How did those resources get to be in this bundle, in this group? So the bundle is the mechanism that allows us to exchange several resources in one single bundle. So it allows us to list and to contain those resources. Besides the bundle resource, there are other resources that are used for grouping resources, but not containing them. So the bundle contains the resources, and I'll show the example right away. The other resources are list and composition and the group. We will see an example of composition today because it's used in the messaging and in the documents approach. So looking at the bundle, and this is interesting, but this is more interesting. So my query that I was doing there, if I get everything about the patient, what do I get? Just zoom in. See, I get the bundle because I have a bundle with a lot of entries, in this case 53 entries. That's as many things as the server found about this patient. And you see the entries. So one entry is the patient itself. Then if I scroll down, this is still our patient, but then another entry will be showing up soon. Yeah, another entry is another resource called explanation of benefit that points to the patient. You see here the relation is pointing to the same patient. And if we go to the next resource, it's a claim that points to the same patient. The other one is a, what is it? The next resource, so there's 53 of those, so we should have, yeah, it's the document reference where the patient should show up. Yeah, the patient is there. So this is just a search, as we've seen the searches before, but the key thing is that it shows a bundle because the server has to return only one result at a time. So one resource at a time, and that resource should contain other resources. The way to do that is FHIR. So that is the say the foundation for exchanging resources in FHIR from the REST perspective. And it was a very quick intro. So there's lots more to know about the RESTful approach, and that's all documented in FHIR in this page, in the HTTP page. But from here on, I think it gets rather technical, and the purpose of this session today is to give an introduction on how to choose this, how to choose between RESTful and documents and messages. So how do you start defining your architecture? So it's not really the point to go into all the detailed possibilities of REST, but you can find them in the FHIR specification. It's there. It's relatively it's stable. This one is stable, so you can see all those things like the posts, the gets, etc. How this works in there. Today we are going to look at messaging, which is also documented in FHIR, subscriptions, documents, and we are not going to look at GraphQL. It's also documented there. So just a very brief mention of GraphQL. GraphQL is one way of getting data in a way that you don't need the full resources. You get just show it. You just get one element from one resource and another element of the other resource. So GraphQL, just for record, was created by Facebook because they needed a really a query language that says, I want to see this person and their friends, but only the friends that have the status that are in this group. So these things, you don't need to pull the entire data at once and then do the analytics. You just need to have a very flexible query that says this and what's related to that, and that's related to that. So you need to make this kind of flexible querying. So FHIR has adopted the GraphQL as a potential mechanism to do that. Just to show how the query looks like, you issue a query on the server and you say, I want to get the name. And for the name, I want the text and the given and the family later. And then you do that. And I don't know if this query should work. Yeah, this is an old server, so it doesn't work. So you can issue queries as simple as that. And you say, I want to have, for my observation, I want to have value quantity, but only the value and the unit, forget about everything else. And you can do very complex queries. You can do some logic, and you can link the patient and the observations and all these things. So you can have rather flexible queries. For example, like this one, I want to have this resource. I don't know which one it is. That should be an observation maybe, and the patient. And for the patient, I want to get the birth date, and I want to get the practitioner. And for the practitioner, I want to go there and get the practitioner role and the specialty. So I don't want to have all of this data at once in my query. I just want these specific fields. So this is just a very quick introduction of another way of getting data out of a server. This is mostly used for analytics and for purpose or navigation specific purposes. So if you have an application that doesn't want to bring the patient record in front of you, but you're using this to explore, for example, to explore causality. I want to see patients that have lived in this area and have developed an allergy to or intolerance to whatever, or something like this. If you want to do this kind of navigation like queries, you might not need to have the whole REST search. You might just want to use some lighter querying as GraphQL. It does pose some challenges because in REST you can do some access control to see who can access data. In GraphQL, this is much more powerful, and you can bypass. It's easy to bypass security if that's not built in. So that's just the yellow flag to say, be careful when you choose these things, because all of this has an impact in what you can do in practice. Now, moving on to FHIR messages. I see something in the chat. So messages. In FHIR, messages are bundles. So that's where now things become kind of following a pattern. A message is a way of exchanging data, typically between two parties, between party 1 and party 2, where party 1 and party 2, they know exactly which one is which. So, or when the sender knows to whom it should send the message. If it's it's a point-to-point communication. If you want to send a point-to-point communication, this is one of the criteria, for example, for selecting messages as a communication approach. For example, the lab systems, they use messages a lot because it's between the central lab management system and the device or the lab room that does that kind of procedure. So they know exactly. It's really kind of a closed circuit when you say this. I know exactly who I need to send this. So it's a point-to-point communication where you know the destination of the message. How does messages work in FHIR? You explain the source, which is the sending party. You have the destination, which is the person or the entity that you want the system that you want the message to go to. And you say the event, which is, hey, this happened, or this is the trigger for my message. For example, I have a new lab result, or I have a new request, or I have a new prescription, or I have something, an update. And if you do that, then you need to put that information in one resource called message header. So there's a message header resource which you use to contain the source, destination, and event. Sorry, and and you have and then you put the resources. You put the observation resource and the device and the patient. So you can say, I have a new result for blood tests, whatever, and then you can say, okay, for this I need to have the patient for which the result is for. I need to have the observation, and I need to have the device that produced the observation. Okay, those are 3 resources that you need to send, plus the message header resource. you put all those 4 resources together in a bundle, and that's how a message works. So this is a very short summary of what is in the messaging page, but this is why we have bundles. And in this case, the bundle is of type message, and the first entry in a message bundle is message header. So that's a constraint. So in FHIR, if you look at the specification there, you'll see that when you use messages, it has to be a bundle, and the first entry in the bundle has to be a message header. That's it. After that, it's your own content, but the first one has to be the message header. And the message header is the one that points to observation and device and to patient. So it's one of those listing resources. And that's pretty much the introduction for messages. So this is where the messages, how the messages come to be in a FHIR resources. Everything is a collection of resources, and because we have to put them together, you just put a bundle around this with a specific flavor. That's pretty much what there is to it. When to use messages? When we have a request and response workflow. So when you know who needs to ask and what is expected from the other party, when we have A tells B something and B tells C something, when you have this that there's a request, there's a response, there's forwarding. When you have this hard-coded, I would say, then then messages is one of the solutions, or can be a solution. Also, when you need to drive behaviors that are a bit more complex in a single resource. For example, if you need to have, let me see, if you have a lab system, not a lab system, if you have a patient administration system saying, I need to combine the data for patient 1 and patient 2. In that case, you really need to bring the data about patient 1 and the data about patient 2 that you want to combine. And in that case, you don't want to say, here's patient 1, here's patient 2, now do something with it. Now you say, here is one single box that says patient 1, patient 2, and everything you need to know about this. We need to merge this thing. Or when you have more complex queries, I don't remember any example of that. But it's pretty much the same thing. When you have to put things in a box and say, I know exactly what's expected from this, and who is the person, or what's the system that's going to take care of this, then you can take this as a message. Messages are also used when the exchange is asynchronous or indirect. When you say it's whenever the event happens, talk to the lab system, for example, or talk to the lab system whenever there's a new result. So when you have that kind of exchange, and when you don't want to have a RESTful. So if you have a RESTful approach, you make the request and then you wait for the lab system to communicate back the responses. But in this case, you don't want. You just want to make one request and get one response. So if you have lots of information coming in, but you don't want to have, here's one, here's another, for all reasons, for consistency, etc. You just want to have one single package that brings the whole thing together. Then you can use messaging for that. Next to this, there is FHIR subscriptions, and I think this is the time we hand over to Luke, our colleague that is much more of an expert in these things than I am. So, Luke, take it over, please.
Okay, sounds good. You can go to the next one. So subscriptions is unfortunately one of the interesting parts of FHIR right now, where R4 is the current release. They're going to come out with, I suppose, kind of a minor release soon, but R5 really changes things. So the way subscriptions work right now in R4, which is going to be that way probably for another year or two, or maybe Jose would know exactly the timing, but the way subscriptions work is you basically define a search criteria for what you want to look at. So you may say something like, give me all of the patients with this name. That would be kind of an odd one to subscribe to, but you could do that. Or maybe you only care about one patient and you want to make sure you get all the updates for that patient. Or you could you could get more complicated queries about which patients you want to be notified for. And basically what you do is you just create, oh, sorry, I see your question. A subscription is basically a way to say, I want to know when changes happen to one or more resources. No, go back to the other one. You basically say, I'm going to subscribe, and then anytime something changes to that resource that fits your search criteria, it will the server will then send you an update to say, hey, here's this patient changed, here's the patient details. Although it could potentially be a little bit more complicated than that. So you put in your search criteria to say, here's what I want to be notified about. Again, that could be based on an area, based on a hospital, based on anything. I mean, any FHIR resource you can subscribe to, and you basically just give the search criteria that is there, and that would be following the normal search, as Jose mentioned. From you could look at the previous webinar to see what in anything you can do for searches. This is a FHIR resource. All of these are FHIR resources. But subscription is a special type of FHIR resource. So when you create your subscription, you say how you want to receive those updates, and you basically have to tell the server either you want a REST hook, which is basically just means the server is going to send you updates just like a regular FHIR query. So it would say, hey, I updated patient 123, and here is the content of that. You can use WebSockets, you can use email, or you can do a FHIR message, just like what we just talked about. That would include a message header and the details. A lot of these channels, some of them, for example, a WebSocket, you could configure it. It won't necessarily send the content because you're not sure. There may be issues with security and what you want to allow. What data to be transmitted. You don't want to expose data that you don't want theirs. So one thing that could happen is for example, the WebSocket, it would just say, hey, there was an update to this subscription, and then the client that receives that would then have to do the query to say, oh, hey, give me any changes since the last time I looked, or they would basically have to run their search to get the contents to make sure that they're logged in and they want to do anything. The channels, that's how you would have to set up your channel to say, hey, I'm going to either I'm a regular FHIR server and I'll use REST hook, or I've got special things and I just want to receive a FHIR message, or again, WebSockets is more about the ping. So you can configure them to say it's going to send the actual FHIR resource that changed or was created, or it would just send you a notification that something has changed and you would have to do a query. So again, the workflow that you would go through is you basically use that standard REST to say, I'm going to create a new subscription resource, and you define everything that you need to be there, which again is the search criteria. And you're going to say, here's the URL I want you to send to whenever something changes within this. Again, it could be that you could say, hey, this patient just came to see me. I'm going to create a subscription, so whenever patient 123 changes, I want to make sure I get those updates. And here's the place to send it. So in R5 they've changed. They've made it a bit more complicated. I think this is still a work in progress, so some of this could change. It's still based on that subscription resource, but now the server gets to take a bit more control. So there's a list of subscription topics, and that's where you define kind of how the search criteria. So the server could say, hey, I allow you to look up a subscription topic, which could be around, patients that have this, or observations, lab results, anything, any FHIR resource. But the subscription topic basically just defines the search criteria. So a client could come in and say, hey, give me all your topics, and it can find a topic that it's interested in, that it wants to get updates on, and then it creates a subscription that refers to that topic. And then everything else kind of works the same way. You still do your the channel that you want to use, whether it's a REST hook or a message. But then it's a little bit different when it sends the notification. It's actually going to send a bundle that has the subscription status and the resources potentially that change. So it would have a bundle of the results that matched that subscription, the update. Also, since subscriptions are asynchronous, there could be issues, there could be problems. Perhaps if you register your endpoint and your endpoint is down, you know, there's an events operation where you can say, hey, give me all the events that have happened for this subscription, because it could have been missed because, you know, my server was down for 2 days, and so I want to get all the updates for the last 2 days. So it's a bit more powerful, but it's, like I said, it's still a work in progress for FHIR R5. You can go ahead to the next one. So just to kind of give an example, there is the patient master identity registry uses subscriptions with a message channel. There's kind of 2 parts to this. One part is there's the mobile patient identity feed, and it uses FHIR messages. So there would be a message header, and basically what happens, there's 2 ways you could, you know, potentially manually register your endpoints to say, hey, these people need to get updates when a patient changes. So anytime a patient changes, it'll send out this FHIR message to everybody that wants to know it. And if you don't want to manually configure it, you can use FHIR subscriptions, and it uses that message endpoint type to say, hey, I want to subscribe to the patient identity feed, so that you let me know when any patient changes, so that you can make sure your content is up to date. So that's there. So then we can, the next topic was about FHIR documents. You can go ahead to the next. FHIR documents are, again, a special type of bundle. This type equals document. It starts with a composition resource. The composition defines everything that you want in the document, and then basically you would create an instance of that document based on the composition, and it pulls everything together. For example, here there's an observation, there's a device, there's a list, there's a condition. All of that gets created into a document, and then basically the document becomes a historical record. You don't really, I mean, you can potentially change it if there's a problem, but ultimately you don't really change that document. You can always create a new version of the document from the composition, but you don't really change it. You can go ahead to the next one. I think it kind of talks a little bit more. So yeah, the point of documents is that they're going to persist. You say there's one point in time. Someone can sign the document, for the doctor could say, hey, I saw this observation, I'm signing off on it. And since they've signed off on it, you can't really change it, because if you make changes, that's not something they signed off on. A document, when it's created, it has a set identifier, and that identifier never changes. You can potentially update it to say, hey, this was an error, or this has been superseded by a different document, but ultimately that document should live forever, or based on your document retention policy. The benefit of the document, as it says here, is there's you can have multiple resources that all kind of tie together, and that's all linked to that composition resource. The composition just says, hey, it's this patient is the subject, and it was this observation, or maybe and this medication was given because of it. So you kind of have that one document that you can live forever, that has the bundle of FHIR resources. Jose, I don't know if you wanted to cover anything else with documents.
Well, just one simple thing there is that indeed, so I think the fact of persistence of the set. So if you talk about REST, you can access one resource at a time. If you talk about messages or documents, and most important documents, it's one snapshot. So if you say these are the current known allergies for this patient, this is something that, for example, you'd want in a document, because if tomorrow a new allergy is found, then you can put it on the server, but no doctor has signed off and saying these are the known allergies for this patient. So if you want to have some consistency around the data and saying someone signed off on that, this is when accessing to the individual resources versus accessing to a snapshot of a set of resources, that it makes sense. I just wanted to bring that example to see if I don't know if it helps.
Okay, yeah, thanks. So one way to work with documents, IHE has published a profile called MHDs. MHDs is mobile access to health documents. It's a way to share your documents. MHDs is defined for a FHIR only infrastructure. It's based off of MHD, and MHD is meant to be kind of a FHIR front end to other document sharing repositories. So MHD, again, MHDs kind of pulls together a lot of things, and it kind of defines all of the services you would need, but it ultimately is based off of the MHD transactions. But it's meant to be 100% FHIR. You have your document registry that's, people that create documents can save them. Like I said, it uses all the MHD transactions, and you persist these documents. But what MHDs tries to do, it pulls together, you've got your patient identity management. So it talks about how you track what your patients are to make sure you have access to those as FHIR resources. Your authorization, who's allowed to see these documents, whether the patient is given consent for various services to read them. Also the trust, again, the trust is a little bit different. It's just making sure that, again, that you have access to be able to look at the document at all on top of the consent. It also talks about vocabulary with your code systems and value sets to make sure your terminologies are defined well. It also makes sure there's auditing done a lot. When we come to looking at patient and medical records, you want to have a trail of who's looking at it, when they're looking at it, and MHDs defines how you would do that auditing. And then of course the provider directory to make sure all of these references to the health worker that's doing the work is defined. So all of these are FHIR, and again, it pulls together all of the IHE profiles that manage these type of FHIR resources and what transactions you would use. One step that you can do, this is kind of how to define if you want to use MHDs or not. We don't necessarily need to get into the details, but people that already have a document sharing framework, they might just need to use MHD. But if you don't have anything already and you want to go with FHIR, that's when you would go with MHDs. You can go ahead and go to the next one. These are the actors that are in MHD. So the main part of MHD is someone's going to say, hey, I've got a document and I want to make it available. So that's the document source, uses the provide document bundle to the document recipient. And it's just saying, hey, here's a document that has been published and now I want to make sure it's available. That effectively is a bundle. There's a submission set. Again, we don't need to get into the specifics there of what is there, but it is a FHIR bundle that includes the document with document references to where it needs to live. And then once you have basically saved that document, and most times your document recipient would also be a document responder. It's going to be a document registry that people can then search on it, and that's where the set of transactions on the right. The document consumer is going to query the document responder to say, hey, give me these sets of documents that I want, or find a particular document reference, or just to retrieve one document that lives. As Jose was saying, if you've got an allergy list, someone's going to come in and say, hey, give me the allergy list for this patient, and that's where you'd use the retrieve document. But if you needed to do more complex searches, the other transactions kind of handle that for MHD, and again for MHDs whenever it's a FHIR only environment. You can go ahead to the next. I think that may be the last. Yeah, I'll pass it back to you, Jose.
Thank you. Yeah, so while this was an introduction to the mechanisms, I think the most important part is, okay, now that we know what REST is for, what documents are about, and what messages are about, and what subscriptions are about, how do we choose them? So that's the part that becomes very fundamental, important in any decisions, because this determines your entire architecture. So you have to have you'll have lots of criteria. So is this a point-to-point or broadcast? So point-to-point is that when I create content, I know exactly who is going to consume it. That's typically messages. Or is it broadcast? So broadcast is documents, or if it's a bundle of resources, or it can be REST. REST is also broadcast. I just make the server available and someone can consult it. What about integrity? Is it important to keep things together so that if the patient dies of an anaphylactic shock from another allergy that was not detected, do we want to have a snapshot of what the doctor signed as these are the known allergies for this patient? Is that important or not? Or in a discharge letter, discharge letter contains what is currently known and found relevant. If something else is found, then the hospital is not responsible for what was found afterwards. So is that integrity important or not? Idempotency. So basically this means that if you issue the same content twice, do you expect the action to be performed twice, yes or no? So if you make a document and if you just say, well, here's another version of the document, does this mean that the systems that receive it must do something specific, or we say it's just an update, just read the updates? For example, when you send a message to say, please make this test for this patient, if you repeat that instruction, you actually would mean normally, please do it again. So that one is not idempotent. So if you say an idempotent communication is when you say, if I say something one time or three times, the result is one and the same. Or if I say one thing one time or three times, the result is one or three times the same result. That also matters for your decision. And if it's asynchronous or asynchronous communication, so if the systems will need to exchange information immediately when they know it or when they get the request, etc. Without going into that whole tree here, there is a nice FHIR implementation guide that explains a lot of this. It's produced by the FHIR community, so you can rely on it. See, it has lots of details here. It's REST, but it's REST search, and it uses polling, which is another mechanism that we have. It has the REST create update. So all the details that we have briefly mentioned here, and it puts them all into one picture, which is, well, who initiates it? Is it the consumer that wants the information, or is it the creator that initiates the communication? Okay, depending on that, you are in different points of this map, and then is it, does it require human intervention or not? Is the data existing or not? So I think this mapping here, the link that we put there, should help you figure out where you are in the search. And then you have, for example, you have subscriptions. If you have subscription, then you use subscriptions with a query, for example. Or if you don't want to have subscriptions, you just call the server. You just ask the server anytime that you need the data. Or if you want to have just individual updates to resources, or if you want to have documents or messages somewhere, or GraphQL. Like if you want to have an alternate query here, then you use GraphQL or CQL. It's just another way of querying FHIR. Yeah, so this is a big diagram with a lot of details. And I just wanted to leave with one additional consideration, is that whatever you do here also has an impact on, for example, security and privacy. If you want, for example, to have document infrastructure, that determines your architecture in terms of types of systems. What are the data flows? How do you preserve integrity of the content, which with a document is simple, but with a message is not so simple, or REST is not so simple. You have to build something around that. If you have access control, so who can access which document, that's a simpler question to answer than who can access each resource, and the type of applications that are expected. So the application that reads an entire document will have simpler display logic, but maybe different rules than an application that reads resource by resource, and that impacts things, and especially the security and privacy part. You might be talking about encryption of data, because if you know who the message is going to, then you know you can trust that party. But if you broadcast it, you have to have additional layers of control to see, can the party safely access the data? So this is why I said that this will impact. So decision between documents and messages and REST will impact your architectural decisions, and that's why it's important just to have this overview. And I will stop for now and see if you have anyone has any questions in the 2 minutes that we have left. Any ideas, any questions, any follow-up?
Yeah, Carl, I raised my hand. I have several questions. One is, when you talk about documents, can only the data producer define the document, or can I, as a consumer, define my own document and apply this to the file resources of the data producer?
If you create a document, then you are a document producer. Those are roles that the same system can have. Those are not types of systems, those are roles. So you can have a system that is a consumer and a producer of documents, depends on what your purpose is. So you can consume documents from lab system or whatever and issue a discharge letter. In that case, you are consuming and producing resources. I don't know if that answers the question.
No, I meant, let's say I'm Dr. A and I have access to the data of a hospital. Can I, as a treating doctor, produce my own document to get data from the hospital where they had undertaken some examinations of my patient? Or do I just have to take the data in whatever structure the hospital delivers them?
No, once you get the data from the hospital, those are FHIR resources. So you can disassemble that and you can unmount that and create your own document based on that. So the fact that data is supposed to be persistent in a given way, that's in the communication. After you receive it, well, as long as you respect the rules that are there so that you don't, make up some information or that you don't remove any relevant information, that's the doctor's decision, then there is nothing technical that prevents you from saying, I got this document and I'm going to completely disassemble it. I understand the need for persistency, but now I want to use this information in another way. So there's nothing in the document that blocks and says, from now on, this must always be one document together. You can disassemble it.
But you still don't understand what I'm asking.
Sorry.
I say I have this document structure, and this is different. Like a discharge letter is my discharge letter structure, for whatever reason, is different from the discharge letter structure of the hospital. Can I then impose my own structure and extract the data from my structure from the hospital, in spite of them having a different document?
No, normally you can say to the hospital, give me a discharge letter of model A. You can ask this, but it depends on the hospital if they know what model A is. So you cannot, impose that.
They would not allow me to access the data itself, but only the data in the document.
There is a possibility in FHIR that you say, here's the document definition, please create a document for me. There is an operation in FHIR that you can say, create this type of document for me. It is possible, depends on whether the server supports it or not. So if you have a document definition and if you can issue that request and if the server accepts it, then sure, you can do that.
Okay, thank you. Second question, how does this relate to CDA, or is CDA something totally different?
CDA is one document architecture, which is exactly, so FHIR and CDA, those are two technical implementations of the same thing, which is a document with structured content inside. So CDA and FHIR, those are just two technologies to do the same thing.
Okay, thank you.
Okay, any more questions? Thank you for those questions, Carl, they were very interesting. Any other things for us to discuss? If not, then thank you for the very quick flyover of these things, and I hope it has been useful. Please send us feedback in whatever way you want. We are glad to just go into more details on the implementation of any of these things. For example, on the constructing documents based on document models. That's also an interesting topic. Please drop us your feedback, and I guess we see each other soon. Thanks, Luke, for
can I have one last question?
Of course.
What I'm wondering all the time, what you present here, is this an input for the software guys? Or does this mean such a system I can buy off the shelf? Or what are you really doing here?
What we are presenting is the base specifications of FHIR, the technology constraints that normally developers, they should be aware of when they make their system. So they know when they create the document to present to the doctor, they should know how to request this document from the doctor. They should know, is it the document, is it the message, or do I get the resources one by one and then present it to the doctor? So what we are discussing is how a developer, the things that the developer should know to create the interoperability layer, so the interface layer of their software.
So I can have 10 different software systems who in the end deliver all the same.
Voila, interoperability. That's the purpose.
But why not have one? 10 are too expensive.
That's the eternal question. The best way to guarantee interoperability is everyone just goes to the same system, but that's not what we usually are about. We want to have several systems able to communicate with each other.
Okay, thank you.
Good.
Very helpful.
Thank you all then. And yeah, please let's follow up by any means you want. Luke, thank you very much for the documents part. Thanks for bringing your expertise there. And to the rest of the community, thank you very much, and hear you soon, and have a good day.